Assalamu alaikum. Now we are going to perform our third assignment assigned by our worthy teacher Mr. Muhammad Jamil and for the subject digital image processing. So for this we need to know about basically what is canny edge detection. So canny edge detection is a widely used image processing technique which is used to find the boundaries of objects within an image. Okay, and basically our main objectives in it are good detection, good localization, and the third one is minimal response. Basically it detects all the edges and location of edges are located here accurately where actually they are in real image are located. Similarly, we can see that for minimal response only one edge should be detected for each actual edge, even if the edge is blurred. Similarly, we can say that canny edge detection consists of following steps. These are 4 steps of canny edge detection technique, which are noise reduction, which reduces our noise in the image, and gradient computation. It calculate for magnitude and direction for each pixel. It calculates magnitude and direction for each pixel, and it is also used to identify edges. And the third technique is non-maximum suppression, and basically it is for knowing that the pixel is not maximum in that particular direction. It is suppressed to thin the edges. And the fourth one is hysteresis thresholding, in this we have 2 thresholds which are used to further refine the edges. Okay, canny edge detection has its advantages and as well as its disadvantages. So moving on toward our task 1, which is shown in the screen as step 1, which is showing the Gaussian smoothing. To perform actually to run these 4 codes of all these 4 steps, we have assigned 2 functions to this code. First function is named as hysteresis thresholding, and the second one is non-maximum suppression. So this is shown hysteresis thresholding, and here it is the non-maximum suppression, as we can see this. So these are our functions, and when we perform this our first step as which is Gaussian smoothing, as the word shows that it will create smoothness in our image. We can say that display we are given an original image, and it will make our image clear and it will look like this image. As we can see that there is a huge difference in these 2 images, as original image has sharpness, and while smooth image is smoothy, and we can feel it. I think we can just see this, that there is low smoothness, there is high smoothness and low sharpness. Similarly, moving on, we have another step which is gradient calculation. We will calculate the gradient of the image as this code shows, and we perform this code we run it on MATLAB, which give us a result like this figure. And gradient magnitude actually I will say that it ruined our image, as it is blackish and all. We cannot clearly see the image of this leopard, as it is completely changed. So this is our gradient magnitude, which is the second step. And moving on toward the non-maximum suppression. For this we also design a code and run it over MATLAB, and which give us a result like this. So for the gradient image we perform maximum non-maximum suppression, and it is vanished actually, almost. It is vanished almost, as all area of the image and rest is trying to be blackish, and so it is the result of non-maximum suppression. Similarly, here is the fourth step, which is edge tracking by hysteresis. So for this we have subplots and title of original and canny edge detection. We can see that for figure 4 we have the result for fourth image. And so there is an image which is blurry, I would say. There are all disturbances as shown. There is no image actually, I would like to say that, because the original image is clear and we can see there is a picture, there is an object or something else as a leopard is shown. But in canny edge detection, which is we will perform with our code, that there is nothing and absolutely zero. So this was our edge detection technique, canny edge detection technique. So thanks for joining us. It was our assignment number 3. Thanks for joining. See you next time. Till then, Allah Hafiz.